When asked to add or subtract radicals, you need to have two things match. With multiplication, all you really cared about was that it was the same index. When you're adding or subtracting, though, the index has to match and the number under the radical has to be the same as well. So you need to have both of those things going on, and then it's basically like combining like terms problem. So notice in this first example here, this is really index 2. It's a square root index 2, index 2. That's good. And then we have 7, 7, 7. So they all match. That means we can go ahead and we can combine, basically combine like terms. So pretend this root 7 here is really my x, or my variable. I have 1x plus 4x minus 8x. 1 plus 4 minus 8 is a negative 3. And my x is really the square root of 7. So my final answer for this one is negative 3 root 7. You treat it like a variable, and then you just add the coefficients out front. On my second example here, at first glance, we have the cube roots going on, which is great, but the number inside the radical here is not the same. So normally what you do is just stop there, do nothing, you don't combine them, or you can just get decimals and add them together. There's nothing that says you can't just add the decimals. But, as it turns out, if you do a little factor tree on these, the cube root of 54, if you do your factor tree, is 3 times the cube root of 2. And if you do a factor tree on 16, it's going to be 2 times the cube root of 2. So initially it didn't look the same, but if you did a factor tree, you break them down, magically they were the same here. So we can add those together and you get 5 times the cube root of 2. So typically, if the numbers aren't the same, you can't add them, but you should try simplifying them first and doing a factor tree to see if somehow they end up being the same. If there was a different number here at the end, you just wouldn't combine them.